Dalton's model had no information on subatomic aspects. All matter is composed of atoms and are invisible. Atoms of a given element are identical, and atoms cannot be created, destroyed, or subdivided. Dalton's benefits include: it was a start for the models of the atom. Scientists can use this model to make more improved models, helps understand what matter is made of. It is in the starting point of the next investigations with the chemical reactions and atoms rearranging them in compounds. Dalton's drawbacks include the atom isn't indivisible, missing subatomic information like the positive and negative charges.
J.J. Thomson, who discovered the electron in 1897, proposed the Plum pudding model of the atom in 1904, before the discovery of the atomic nucleus, in order to include the electron in the atomic model. In Thomson's model, the atom is composed of electrons, surrounded by a soup of positive charges to balance the electrons' negative charges, like negatively charged plums surrounded by positively charged pudding. The benefits of the Plum pudding model was that it was an advance in subatomic aspects, as the atom contained charges. Also, this model contained electrons, which had been recently discovered. It contained electrons and their balance, a spherical cloud of positive charge. The limitations of the Plum pudding model is that the electrons are not organized, and the positive charge is in a soup. There are no clear protons. Also, there is still no nucleus or neutrons. The Rutherford model is the model of the atom devised by Ernest Rutherford. Rutherford directed the famous Geiger-Marsden experiment in 1909, which suggested upon Rutherford's 1911 analysis that J.J. Thomson's Plum pudding model of the atom was incorrect. The benefits of this model is that the model is now more complete because electrons are organized into orbits. The positive charge is now shown as a proton and located inside the nucleus. There are now the same amounts of electrons as protons, so the atom will be electrically neutral. Also, this model shows the discovery of neutrons inside the nucleus. The limitations of this model is that the electrons revolve around the nucleus as planets revolve around the sun, but electrons revolving in circular orbits will not be stable. In such cases, the atom would be highly unstable and it would collapse. Finally, the orbits of the electrons overlap each other onto the nucleus.
In the Bohr model, electrons orbit the nucleus in orbits that have a set size and energy. The energy of the orbit is related to its size. The lowest energy is found in the smallest orbit. Radiation is absorbed or emitted when an electron moves from one orbit to another. However, Bohr model is a simple way to interpret the atom. The model states that electrons and atoms move in circular orbits around the central nucleus and can only orbit stably in certain fixed circular orbits as a discrete set of distances from the nucleus. These orbits are associated with definite energies and are also called energy cells or energy levels. Drawbacks of Bohr model include: it makes poor predictions regarding the spectra of larger atoms. It does not predict the relative intensities of spectral lines. The Bohr model does not explain fine structure and hyperfine structure in spectral lines, and it does not explain the Zeeman effect. Electron cloud model is an atom model, wherein electrons are no longer depicted as particles moving around nucleus in a fixed orbit. Instead, as a quantum mechanically influenced model, we shouldn't know exactly where they are, and hence describe their probable location around the nucleus only as an arbitrary cloud. However, it shows where an electron is 90% of the time, and it gives a reason why chemical properties repeat. It explains electrons in all atoms. The modern quantum cloud model has some drawbacks. Its electrons are tiny and move super fast. When you measure, it affects the results. And it is a more complex version of Bohr's model, which means that it is more complex to understand.